to, let's see, I don't see Mael. Is Mael here anywhere? Or Lilith, Dawson, Coleman, Shane, Wesley. Am I missing you guys? All right. You are welcome to turn off your video now. I've seen everybody, so we're good to go there now. And let's see. There's a few things I wanted to check in with you guys about. Just kind of general things real quick. I have everything up on the board there again. If you know, I've got the office hours if you ever need to see those. Just, you know, if you can't make the Zoom meeting, just to make sure that you watch the recorded version later. Hopefully this week that works. And then fill out the Google form, because I am supposed to report that I've had contact with everybody. And so that's a nice, easy way to make sure if you don't make the Zoom meeting, which is an easy way to prove that you made contact with me, you can just fill out that Google form for me real quick. And then just keeping in mind, everything you turn in will make your grade go up. If it's not 100% when you turn it in, I will return it to you and tell you what you need to fix so that you can make it 100%. And yeah, anything should make your grade go up and not down. Let's see. In terms of stuff that is due this week, I want to remind you guys we had 4 assignments this week, which is different than what we've been doing. Just because I want to make sure we get all the material covered that you need to see before you take the AP exam. So again, that's 4 this week. It'll be 4 next week, and then 3 the following week, and then that's it. No more. We will probably do our projects. I'll probably do something where you do some sort of a videotaped presentation or something about the project, but that'll be after AP exams, and we'll talk more about that later. But yeah, just this week and then 2 more weeks of calculus stuff, and then you take the AP exam, and that's it. So we're almost there. Let's see. I think that's it on that, on those notes. Let's see. I want to share my screen with you guys, because I want to make sure, if you haven't seen it yet, I did post something in Google Classroom for the seniors to fill out. So if you guys haven't seen it yet, this is something that I do every year with my seniors. Usually it's a handwritten thing, kind of hard to do right now. So if you are a senior, please make sure you you know, get your name on here and just let us know what you're doing next year. If it's not college, that's okay. Just let us know what you're doing. It's no big deal. I have one from a few years ago when Anna Maria Morales was a senior, and she wrote this long thing about how she was taking a gap year, and she anyway, she's it's kind of fun to look back at those. So I did post the one from last year if anybody wants to look at last year's. And if anybody's interested in seeing previous years, I can certainly take pictures of those, and you could do that too. One thing real quick, if you guys will notice, Ryan, it doesn't have the location of his, and that's probably just because I'm guessing you did type it in, but if you hit enter, then it'll make it appear. For some reason, it doesn't appear for everybody if you don't hit enter there.
Yeah, I typed it in. It just doesn't. I don't know.
Yeah. So if you hit enter or click on another cell, it should be fine. So no big deal there. Yeah. So please do that. That is something that it makes my heart happy. So do that for me. It's been really fun getting to see the people that have put their names in there and where they're going. And some people have known for a long time what they're doing, and some people, they're new decisions, and it's just exciting for me. So and I think it's fun for you guys to get to see where each other are going as well. Let's see. I want to make sure you guys are looking for emails from the College Board. You guys should have gotten something last week, and there were probably about half of you that responded to a survey. I got the results of the survey kind of saying if you planned to take the AP exam or not. And so I just want to, and it is totally okay, whatever your decision is. I'm not trying to put pressure on you for that. I just want to make sure that if you are planning on taking it, that you are looking for those emails from the College Board. They probably are not going to your school email account. They're probably going to whatever account you use for signing up for like SAT and AP exams, obviously, and that kind of thing. So, so you need to track that down and find that, because that's probably how they're going to be sending you the, like the invitation to take the AP exam, that you're going to get like a ticket, and it'll probably be through that account. So make sure you are looking for that, because that's something we need to make sure that you guys can find. I have something that I think I shared with you. I scheduled it to share right before this meeting started, but I'm going to show them to you now. They are a couple of cheat sheets, and just a reminder that, you know, since this AP exam this year is an open note test, this is something that you can have in front of you. I've been trying to get you guys to memorize these things all year, and it does help to have them memorized, because it is, you know, the quicker you can recall things, the quicker you'll be able to use them. So anyway, I just wanted to kind of talk about these real quick. It is nice. I would have either one of these there with you when you're taking the AP exam, or your own list of things. You could maybe look at both of these and your list and kind of see what's there and what's missing, so that you have a complete list that you are very familiar with. But I would start using this list now as you're doing these review sessions and doing these practice problems, so it's really easy for you to find the information that you need, like the derivative of ln x is 1 over x, that kind of thing. On this one here, there are some topics that are not applicable to the AB test, and so you can see they're kind of very lightly marked with BC. This one, it's just this little section right here that's BC stuff. So like the, you know, the derivative of position is velocity, the derivative of velocity is acceleration. That was stuff that got reviewed this week. But these things right here are BC topics. This is all AB stuff. And then when you go to the back page of this, almost the entire back page of this, and I probably should say second page, for me it's the back page, but for you guys it would just be the second page. It's almost entirely BC stuff, except for L'Hopital's rule, which is here at the bottom. So if you wanted to print it off, you might just write L'Hopital's rule for yourself, you know, on the other side or something. I wouldn't bother printing that back page. So there's that one. And then the other one is, I think it's not quite as complete as that first one. I think this is the other one. Yeah. It's only on a single page. It doesn't have L'Hopital's rule, but I think it has most of the rest of the stuff. So you just kind of might want to look at the two of them, see if you like one better than the other. They both have pretty much the same material on them. So anyway, those are a couple of resources that I wanted to share with you guys. And like I said, I did post them in Google Classroom this morning, so you will have access to those. Just a reminder too that the one thing that they are really concerned about when you take the AP exam is your time. So maybe making sure you have some sort of a timer set up so that you know when you need to stop, so that you can upload your material, because if you don't get it uploaded in time, you are going to not get that part scored, and that is a problem, because then what was the point of doing all that work? So get yourself some sort of timer set up. Make sure you have your calculators, your cheat sheets, and everything you want ready to go, so they're right there with you when you go to take the test. Keep in mind that the calculator is not required, but because everybody does have access to it, I would definitely make sure you have one. And they probably won't have problems where you will need to use Math 9, but just keep in mind that if you did have to evaluate a definite integral, you should use Math 9. If you had to evaluate a derivative at a certain point, you should just use Math 8. So even though they are not requiring a calculator, and so I don't think it's likely that you'll need to do those things, keep those things in mind, that you should be practicing those skills on a calculator. Let's see, wanted to remind you guys again, just reiterate what I said last week, that they're really looking for cheating, so don't give them any reason to question your integrity. If you're interested in typing, they will have a keyboarding tip sheet. I think I'll have that next week to share with you guys. If you're interested in that at all, you can check that out. I would say that's probably good for somebody that doesn't have very good writing. If there's a chance that you feel like your writing is something that the AP readers may not be able to read, that might be something to consider. Other than that, I think for the most part, you should probably just plan on, writing it out and then doing like you're doing with me and uploading a scanned or a picture of it. Let's see. Yeah, like I said, we should have a lot more information from them April 28th. So next week, by the end of next week, it sounds like they'll have a slideshow, which, I will, I'll share with you guys. You may get it directly from them also, and then I'll probably kind of talk through that the following week in our Zoom meeting. But we should get a lot more information about what it's all going to look like, what it's all going to feel like on the day of the AP exam. Wanted to kind of check into and just say, I know that what I'm assigning you is probably kind of a lot right now because we are gearing up for the AP exam. But I want you guys to keep in mind that I don't want you to feel overloaded, overwhelmed. If you're feeling like you can't do it all or that you need more time, just reach out, just ask. It's really not a big deal at all. We can figure it out. It's no big deal, but I do want to encourage you to reach out. For the most part, emailing me or private messages in Google Classroom works great. I get notifications and see them right away. I don't always respond right away because I get tired of sitting in front of a computer for 500 hours a day. That's what it feels like anyway. But I will respond, as soon as I can, and keep in mind that I really enjoy doing calculus. And so a lot of times I will be like, oh, a calculus problem, I'll go do that. So I do often kind of get to your questions quickly. So yeah, so keep in mind too, we're done learning new stuff. We're just reviewing at this point. We're going to be reviewing through the week of May 8th, and then AP exam start the next week. So we're there, guys. We're pretty much done with our calculus. It's just kind of reviewing stuff. So just a reminder again, I talked about this last week, but we'll be doing the AP live reviews of units 1 through 7. So this week we're finishing up the unit 8 stuff that we kind of covered before spring break. And they're kind of touching on those topics that refer back to some of the stuff that you will be tested on, even though that unit 8 stuff you won't be tested on. But we will be doing units 1 through 7 in the next 2 weeks. So next week we'll do units 1 through 4, and then the following week we'll do 5, 6, and 7. And then they do have another like 7 or more sessions available. And so you guys should keep that in mind that you could do more. Like I said, I'm not assigning anything the week of the AP exams. And so you may find it helpful to go in and kind of pick and choose some of those topics to review that you think would be helpful. And then just one last reminder, the AP exam is on Tuesday, May 12th. It is at 11 a.m. for us, and they're gonna have you checking in a half hour early. So, maybe mark your calendars for 10:30 a.m. on May 12th, because, they're gonna have you guys do a security kind of protocol check-in and then wait in a waiting room until 11 o'clock when the AP exam is actually put out to you. And we're kind of lucky that 11 a.m. time is a good time. It is happening around the world at the same time. So for some people, it's like 3 a.m. And for some people, it's like 5 p.m. So I feel like 11 a.m. is a nice time. And so I feel lucky for you guys for that reason, because I think it would be awful to have to get up at 3 a.m. to have to take the AP exam. I don't think that's really fair to those poor kids, but that's how they are keeping the integrity of the test so that it doesn't get, once it's shared to you guys, then, it could be there for anybody to see. I thought I would take a few minutes to talk about the lessons for this week. the first one from this week from 8.2 is the basic idea is just understanding that if you have a position equation, the derivative of position is velocity. And that if you take the derivative of that velocity equation, that gives you acceleration. And that you can go backwards with that also, meaning the antiderivative of acceleration is velocity, and the antiderivative of velocity is position, but it's really more displacement rather than position. Keeping in mind too, kind of on that note, the next lesson was on accumulation. And so if you are accumulating the velocity, if you're doing the definite integral of velocity, it will give you the displacement, which again is kind of the accumulation of the things being measured by velocity in this case, which is like feet or miles or something. But keeping in mind that the integral from like 1 to 5 is the change in the quantity from 1 to 5. And so if there was a value, like if there was a starting point at time t equals 1, you would need to add that to the change in position to be able to say what your position is at the end of the time. Okay, and that's something that they talk about in the video, and hopefully you guys kind of understood that, but that was something that I wanted to kind of reiterate. Again, that the integral of any function really, but if it was velocity in particular, represent the integral of that velocity represents the change in that position. And then if they're asking for what the position is at the end of the time period, you would have to include what the starting position is before that change occurred. So you would add the change to the starting position. Let's see, when you are answering questions about definite integrals, like they will ask what's the meaning of the definite integral, and I think this is something that's very likely that you'll see on the AP exam, is what's the meaning of something. Just keep in mind when they ask you for the meaning of a definite integral, you need to say 3 things. Those 3 things include what's the time, like if it's at an instant or if it's over a time interval. So it's from time t equals 0 to 3 seconds kind of thing. What is the answer? So, you know, the distance traveled over this time period was 5 miles. And then also be sure to include the units. So again, those 3 things you want to make sure you include are what's the time or the time interval, what's the actual answer, and then what are the units of that answer. Okay, so those are 3 things that they'll be looking for if they're asking you what's the meaning of a definite integral kind of thing. One thing I like they did in the video on those accumulation problems was they showed you how to determine the what the units are when you're evaluating a definite integral. So, you know, they show you to take the units of the function, the integrand, if that's like miles per hour, and then to multiply that by the units of the t, which would, you know, maybe be hours. So then if you took the miles per hour times the hours, then the units cancel out and give you your the units of your answer, which would then be in hours. So that's something that I thought was a nice way to look at that. So if you don't know what I'm talking about, you might look back at the video at that. I think that's a helpful thing too. Let's see. I also wanted to go over from 8.3. They kind of started to talk about number 1, but they didn't finish talking about number 1. And so I thought I would take a minute to look at that with you guys. A lot of people were asking questions about that. So give me just a minute to get my document camera here going. And then I'll share that with you. Okay. I think this is gonna let you see it. Okay, so again, this is from the 8.3. This is question number 1 that they started talking about. They give you the area of each little section in here. right? This one is below the x-axis, so it says the area is 3, but we would normally think of that as the area being like a -3, and then they're a 7. They ask you in this one, well, they tell you first that there's this initial condition that f of 8 equals 4. And then they say to determine the absolute minimum. And so to determine that absolute minimum, we have to figure out the value of the function, right? The absolute minimum of f. And so we want to figure out what are the different values of f. Well, we know one of them, right? We know f of 8 is 4. So then I have a little table that I started to fill out here. And so at 8, I know the value of the function is 4. And then I want to talk about how to find the other values. When we did this before in class, we talked about looking just at the critical points and the endpoints, and that 8 is an endpoint. Obviously 0 here is another endpoint, so I'm going to include that as a value to check as well. I also want to check the other critical points, and critical points, if you guys will remember, are places where the derivative is 0 or undefined. So here is the graph of f prime, which is the derivative of the function I'm looking at. And so I'm looking at where this derivative is 0, which is at each of those values there, right? So I'm going to check 1, 4, and 6. And I think, I can't remember, but I don't think they even said, I don't think they suggested looking at 1. Now, technically 1 is a critical point because it's a place where the derivative is 0. But do you see how f prime isn't changing signs because f prime is positive and then positive again, right? So it's not changing signs, so we're not going to have a minimum or a maximum there. That would end up being a plateau point on the function f. So that's not one that we actually need to check, but I'll kind of show you what the value of the function is there anyway. They did talk about, since you're going backwards, right? We're starting at x equals 8. Since we're going backwards, that means that we would be subtracting this area here, right? Because if I went from 6 to 8, I have a positive area of 7. So since I'm going backwards, I'm going to be subtracting 7. So at 6 here, that's going to be 4 minus 7, right? And then when I go backwards again, this would normally be a negative area of 3, but since I'm going backwards, it ends up being a positive area. So then I take this value here and I would add 3 to that to get that integral there. And again, like I said, I'll check here at this critical point 1 because this is 6. I'm going to subtract 6 because it's a positive, but I'm going backwards. So I have a negative 6. And then another negative 2 taking me back to negative 8. Right, so now I see all of the function values at the critical points. Those are the only possible places where a minimum could occur. And so the absolute minimum is going to be where that smallest value occurs. That negative 8 is the smallest of the y values. And so you would say the absolute, because it says determine the absolute minimum of f, you would say the absolute minimum is negative 8. You might want to say that it occurs at x equals 0. But again, because it says determine the absolute minimum, they're asking for the y value. And it does say justify your answer, and so it is going to be important to show something like this because this is showing that I looked at the critical points. That's something they're going to be interested in. Did they check the critical points? Did they check the endpoints? And doing just a table like this is a good way to show that you found each of those values there. So that's that, and that should help you with some of the other problems similar to that where you are accumulating area, right? If I had to figure out what's the integral from 1 to 4 of this f prime graph, then it would just be the area under the curve here, which is the 6, okay? So again, if you have other questions, I do have office hours. Let me show them again there. Office hours every day after school. So 2 o'clock for you guys, it's 2 o'clock every day. And then special calculus hours at 9 o'clock a.m. on Tuesdays and Fridays. and then an extra hour on Wednesday afternoons too. So if you do need a little extra help, you can come back and see me during office hours. That's been going really well, I think, for the people that are showing up there. And I think that those people are understanding the material because they're coming to those office hours. So just want to encourage you guys, if there's anything that you're having a hard time with at all, those office hours are great, and I can help you with stuff. I am trying to post solutions too to some of the tricky ones, so you can look for those to post in Google Classroom if you ever get stuck on anything. Let's see, check my notes. I think that was about it. Let's see, if you haven't started watching the new video, because there was one assignment that was due Monday this week, one that's due today, another one that's due tomorrow. And so I was going to talk real quick about the one that's due tomorrow, and then one that's due on Saturday. So the 4 assignments this week again are, the due dates are Monday, Wednesday, Thursday, and Saturday. So the one for tomorrow, I'm going to, hold on, can I do this? I wanted to show you a particular screen here. Hang on. And I don't know if it's going to let me do this right now. Let me try again. Are you guys seeing like the video there? So I think you're seeing the video there. And so anyway, this is just kind of a nice, this is kind of a nice visual because it lets you see when you're looking for the area between curves. I just want to remind you guys that you do need to find the points of intersection at the beginning and the end of the shaded region you're trying to find the area of. So that's your A and your B, which are your lower and upper bounds of integration. And then just to take the top Y value minus the bottom Y value. And that's, again, that's a screen directly from the video, but that's just kind of reinforcing stuff that we talked about in class with that area stuff. So let's see, at this point, we have about 10 minutes. So I'm gonna say if you would like to call it a day and say goodbye, if you would just unmute yourself and show me your video so that I can see your face before you go. You can go ahead and go, and then I will answer questions if people have them on any of the assignments from this week. So say goodbye if you're ready to say goodbye.
Adios.
Bye.
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 Later.
Bye-bye.
Thank you.
Bye, Ms. Gressel.
Bye.
Bye, Miss Grassel.
Bye. Okay, so for those of you that are left, what you got for me? What kind of questions do you guys have?
I was wondering if you could go over the second, or at least one of the mini questions in the second question from the
8.3?
Yes.
You
The
could do A
practice.
and B.
What?
You could do A and B for that one.
Okay, so 8.3, you're talking about number 2 here from 8.3?
Yes.
Okay, and Christine, you said specifically A and B? And then Maggie, was there anything specific for you on number 2 that you wanted to talk about?
I just was very confused on it. So
Okay.
anything.
All right. Okay, for 0 to 6 seconds, a screensaver on a computer screen shows 2 circles that start as dots and expand outward. At the instant that the first circle has a radius of 9 centimeters, the radius is increasing at a rate of 3/2 centimeters per second. Find the rate at which the area of the circle is changing at that instant. Indicate units of measure. So what I see there is a rate at a particular instant, and I feel like this might be a related rate problem perhaps. at the instant the first circle has a radius of 9 centimeters, the radius is increasing. So I'm going to start off just by writing, because it says the radius is increasing at a rate of 3/2 centimeters per second. I'm just going to start with dr dt because that's the rate of change of the radius. Okay, so dr dt for the rate of change of the radius. Because it's increasing at that rate, I'm going to say it's a positive 3/2 centimeters per second. And I'm going to be totally honest. I haven't looked at this one yet. So I'm, if you know something on this one and you want to chime in and help out, that would be wonderful. Let's see, at the instant that the first circle has a radius of 9, that is the rate. Okay, so I know that that's occurring at the instant when the radius is 9 centimeters. Okay, so I've written down that R is 9 centimeters also. Then it says to find the rate at which the area of the circle is changing at that instant. Okay, so because it says to find the rate at which the area of the circle is changing at that instant, that means I want to find dA dt, right, the rate of change of the area. So I need to, because like I said, I feel like it's a related rate problem because it talks about the rate of change of the radius and the rate of change of the area, 2 different rates. So I'm going to find an equation that relates the radius and the area. And because it's a circle, that is area equals pi r squared. And because I want to know dA dt, which is the rate of change of the areas with respect to time, I need to take the derivative of that equation with respect to t. So when I take the derivative of the a equals pi r squared, I am going to get, let me see if I can show this here. The derivative of a with respect to t is going to be dA dt, because I'm taking the derivative of a with respect to a variable that is not a, right? It's with respect to t. And then on the other side, that pi is a coefficient I'll stick in front, and then the derivative of r squared is 2r, but again, I'm taking the derivative of r with respect to t, which is a different variable, so I have to multiply by that dr dt. So since I'm looking for the rate of change of the area at the instant when the radius is 9, right? This was information that I wrote down before. I'm now going to plug those values into my derivative equation. So I'm going to put that 9 into the r, and I'm going to put the 3/2 into the dr dt, and then I'll simplify that. And you can even include the units in there. When you include the units in there, you'll see the units cancel out, so that dA dt is going to end up, or not cancel out, let's see, when I multiply them, we'll end up with square centimeters per second, which makes sense for the units of the rate of change of area, because its area is measured in square centimeters, right? So I'll leave that one there, and then if you guys want, we can talk more about it later, but I think that at least gets you through most of it. In part B, I'm going to go kind of quickly here because I'm almost out of time. Let's see, the radius of the first circle is modeled by this, where WT is measured in centimeters, T is measured in seconds. At what value of time is the radius of the circle increasing at a rate of 3 centimeters per second? At what value of t is the radius increasing at a rate of 3? So we need to figure out, okay, you guys are going to be tested on kind of understanding how to interpret these. So really take time interpreting them. It says at what time, so we're looking at the value of t, is the radius of the circle increasing at a rate of 3. So I want to know when the rate is equal to 3. And that's a positive 3 because it says increasing at that rate. Well, what rate do I want to know is equal to 3? I want to know the rate of change at what time is the radius of the circle increasing at a rate. So the radius of the circle. Okay, so what is this WT up here? What is this function here representing? The radius of the first circle is modeled by this, where W of t is measured in centimeters and t is measured in seconds. So this right here is the radius. It's not the rate of change of the radius, it's the radius, right? So how could I find this rate of change of this radius? Well, I would take the derivative of that and set that equal to 3, and then solve for the value that makes that equation true. Okay, so again, the rate that I'm looking for, I'm going to find W prime at t, and then see what value of t makes that derivative equal 3. I think that's what you have to do there. Okay, so pretty much out of time. Anything else that you guys want me to look at, and I will write it up and have it ready for office hours today. Go ahead and just jump in and say what you need if there's anything else you need, and I'll have it ready for you at office hours.
I need help with number 4 on the 8.3 like practice.
Number 4, 8.3. Okay, so that's the one that I thought would be kind of like number 1. So try it now that you've seen number 1 and see if that helps, but I'll definitely have that ready for you for the office hours. And if I have a chance, I'll try to answer it for you, kind of get you going on it before that too.
Okay.
Okay. Anybody else?
Mine's that 8.4, that number 12 that I had, and then like the one where it has answer 4/3 and 9/8.
Okay, so that's 2 different ones. One with an answer of 4/3 and one with an answer of 9/8.
Yeah, and then an answer of 196/3.
So you have 4 questions then.
Yeah.
Okay, gotcha. All right. Anybody else? All right. Well, maybe I'll see you guys at 2 o'clock then. Bye-bye.
Bye.
I may struggle.
Bye, Ms. Grasso.